We're off, yeah.
The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea and Mauna Loa volcano update. Today, Thursday, August 19th, 2021. We're just a few days shy of the 3-month milestone of the last lava visible in Kilauea, so we're going to recap the monitoring signals on Kilauea, and in that kind of context, we'll take a look back at the eruption volumes compared to some historical context, kind of quick, and then we'll make sure we take some questions that you guys can submit to Dane, who will also be monitoring our streams. Let us know if you have any issues with the audio or the video or anything like that. Submit your questions that we can all discuss. Not to say that we have all the answers, but we can talk about what kind of things make sense. And yeah, we'll then go through and look at all the new USGS photographs and review Mauna Loa as well before we wrap it up today. So that's what we have in store today. If you want to add anything, Dane, feel free.
Yeah, we will be doing another episode of Drones On immediately following this live stream. It's going to be on June 8th and 9th of the 2018 eruption. And we're going to be looking at Kapoho yet again and back up to Fissure 8 and some of the relief efforts that are going on in the community. So yeah, stay tuned. The video will premiere after this live stream. Give it a few minutes. Short little video though.
Right on, awesome. We'll look forward to that as well. Mahalo Dane. So we'll get started today with this view of Kīlauea. This is looking from that down drop block on the eastern side back to the west to that deep pit of Halema'uma'u, that deepest crater at the summit of Kilauea volcano. And you can see this is one of the photographs taken during a USGS fieldwork that we'll recap a little bit later. You see this? Oh, that's not what I want. I don't want text. Where's my drawing tool is not behaving as expected. Just 1 second, I get it back up here. All right, now I can draw. So this is the profile here of that 1982 spatter rampart that's down on that down drop block of the Caldera floor right there. So part of this fell into the pit over here, and part's still visible over here. And this is just a little bit of a different view that we don't usually get, that I thought I'd open up our sharing today with you guys. And we'll focus more on the USGS fieldwork photographs a little bit later. For now, we will move on to some of the monitoring signals in the volcano. And to start us off, we'll look at the visual range here. This is the most recent photograph we have taken from that western rim, and you can see everything's crested over. It hasn't really changed in its appearance in a while. Zoom it in for you guys a little bit there. So we'll move on from that. You can see the thermal image here. Thermal hasn't changed a whole lot recently as well. We still have that similar temperature range, similar spots of heat. Not a whole lot of change there. We can move on from that as well. SO2 emissions, we have a new one that was around the 12th perhaps, and it's somewhere between 50 and 55 tons per day. So fairly low, definitely within that background range. It's lower than the last two that we've had. You might be tempted to draw a downward line, but these things vary all through this range, and in fact even wider than this. So it's all within that variable range, and it just happens to line up on a downtrend here. I wouldn't take anything out of that necessarily. Apart from that, it's still within that background range, and there's not a whole lot of gas coming out, regardless of what's happening underground. So we have seen some interesting changes on the depth of that crested lava lake. It seemed like if we look at this average value through here, like it had a couple of dips, 1 and 2 here, and it seems like it's fairly stabilized since then. Maybe it's dropping, or it's hard to tell within that variation there, but certainly it looks like it hasn't done that in the last week or so here. This is a month-long graph. So interesting to note that perhaps it could be some cooling process underneath that crust. It's all liquid under there still, and will be for decades. And it could also be some of the tilting of the ground. We know that the ground is swelling as magma is coming into the volcano from below, and it could be tilting things locally through there, and it could be essentially allowing that liquid to redistribute a little bit and perhaps flex that crust or allow it to rise and fall in some interesting manner. So those are all just speculation there, but those are the kind of things that would be candidates of processes that could be going on here. All right, so that's the graph. And so I wanted to just move right into this quick reflection. This is a plot that I made, and there's a lot going on here, but I'll start off here in the top part. This is the USGS profile that they've shared, with this orange line being the profile before the 2018 collapse, and then the black one being afterwards on here, right? So it spans the whole Caldera width here, the yellow and the black. We're looking at that first. That's the overall shape there. So focused in the middle, we can see that we had that deeper collapse right there. But we also had this down dropping of that down drop block on the side there, and a little bit wider area of collapse there. So all I've done here is I've taken Thomas Jagger's old cross-section picture of the filling of the lava lakes from the 1924 on, right after the explosion of Halema'uma'u, and that opening of that pit. So I put it in here. This was the shape of that pit and how deep it actually went. It didn't quite get to the water level. It was down there, but not quite that far down. So it was a little bit similar in shape in some ways, but certainly not as wide. We didn't have this other extent to the side here and here. And you can see that in those first 10 years or so after that explosion and formation of the crater, the lava filled back in. I have it written over here on the side. I filled it in 580 feet, 177 meters during that time. Right? So it's not too different from what we got to 200-ish during that 2020-21 eruption. That eruption that came afterwards in 52 was also pretty big, 300 feet, 91 meters. And of course, these are just depths in the inverted ice cream cone. So just the depth only tells you so much. You really want to get at volumes as well. So interesting just to see the comparison that now our current lava surface sits above, but not too far off of the bottom of that collapse pit of 1924. It sits right around where the 1928-29 lava would have been covering it at that point in time. Right, it erupted as far as depth, a similar amount as it did in those times, right? But let's move on to look at the volumes. So over here, I've plotted on, we'll start at the bottom here, on this bottom axis. This is a volume in millions of cubic meters, so 0, 25, 50, and going up in time. So the oldest time is down here at the bottom, 1924, and up at the top, 2020, 2021. Right? And so this is only some of the eruptions. And you can see that here we were at 41 million cubic meters in 2021 eruption, right? So lots of these other eruptions are pretty small. They don't give you an exact volume, only that it's less than 10. And then here's that range of 10. So most of the eruptions you can see are quite a bit smaller than the one we just had. There are a couple of exceptions to that. One is 6768 here within Hale Ma'u. That was the biggest summer eruption that we've had in historical time here, post the 1924 era, because before that 1924 explosion, there was lots of lava lakes, and the eruption was essentially continuous with lava coming up and through all the time. So kind of a different regime. Hard to compare that to what was happening afterwards and what's happening now. So within that new era, right, 67, 68 is the one that's the longest. If we look back to 59, Kīlauea puts that about 50 million cubic meters. Right, compared to our 41 in 2020, and before that, the 52 eruption put out 50 as well. So those two eruptions are the ones that are of similar size to the one we just had, and there was one larger than that, essentially, right? That's kind of the long-term trend in context. And you can see that most eruptions are very short, or they put out not as much lava. They actually can put out quite a bit in a very short amount of time, but they don't last as long, and that's something that's in common of the 67, 68 eruption and of our 2020-21 eruption, as they were both fairly long-lasting, with this one being a 9-month deal, 8.5, 9 months, so quite a bit longer than what we had, and definitely the next level up from what we saw. So that's our context. It's interesting to look at this only because we're coming up. We may be able to declare this eruption officially over early next week, and then it'd be interesting to put this eruption to kind of tie these bows and put things in context here in the rankings, so to speak, right? For those who like the statistics part of things here. So I thought I would just blow it up here as well, so you could see a little bit closer. I did put in 52 lava flow, which was actually pretty decent volume as well. And then above that would be mostly 67, 68. But post 52, you start having collapses, and it's not quite as easy to just layer them up on top of each other like this. So I chose to just stop drawing it right there. But as you can see there, that's the amount of filling, the shape of the crater. Some similarities there, right? And one interesting thing is, now that I've put in this by date here, this bottom yellow line indicates that first 24 hours of eruption and how much it filled in that time. And so just in that time, you see we filled quite a bit. That was really the big burst of this eruption, was that first week, in those first few days especially. Then in that time, we really did quite a lot of the work. So that's our context. So that's the little special extra we have for you guys today. And we'll move on to what's going on now post that, right? So here's the earthquakes. The earthquakes have been the most interesting thing on Kilauea. And here's earthquakes per day on the left. Here's our time on the bottom, past month here. So for the past few days, it's been a little bit higher. And that follows a few days of it being a little bit lower. And that follows a few days of it being a little bit higher. And so it's definitely been variable. We have seen those higher rates. And when I was getting up to here, it was a question of, well, can it sustain that? And if it can sustain that for long enough, we might be more convinced that it might be getting ready to pop and burst somewhere. But then it didn't. It went back down, and it stayed down. And we thought, okay, well, is it possibly stop? Well, no, you have to wait and see if it sustains that as well. And it hasn't. It keeps flip-flopping back and forth. And there's a little bit of a bump over here. And we'll show you guys the reason for that here shortly. But first, the map. Here's a map of the last week, so you can see the pattern of the earthquakes. And actually, a few days ago, this looked a lot emptier than this. It was looking shockingly sparse here, right? but it's filled in, especially in the South Caldera area right in here within the last few days. But otherwise, we still see activity. I'm going to zoom it in quite a bit. We still see some activity tracking this upper East Rift Zone / East Rift Connector area right in here. You still see the south flank adjacent to that area, and south of the summit still showing activity as well. Not just there, but especially there, but also more expanding further over to the east. You can see the south flank active all the way still to 130. Right? Not. I mean, they have a few big events, but mostly it's small events. Not a whole lot of big events, and not anything to speak of really on the rift zone itself. Whereas over here, this is that seismic southwest rift that we've pointed out before. It's interesting to see that that's the one that's active this week, and that doesn't mean anything in and of itself. Only to show that that's all connected, and we can consider that this phase, right, whatever these few days of eruption are preferentially filling an area like this. And an analogy I've used before is something like filling an air mattress. And the whole air mattress doesn't lift up exactly at the same rate everywhere, right? As you fill it up, you might get one corner stays flopped down, or the other corner stays flopped down, and eventually that one area, the pressure can move across that fold and then swell up that corner or the other corner, and it's something like that. The volcano's got different pathways, and the pressure can work around in different ways. And it can change from week to week where you see those flare-ups happening. It was interesting to see that last week we had a little bit of a flare-up over by Kīlauea, right in this area over here, which is similarly along that South Caldera wall complex right through there, right? So imagine as the south flank is moving, maybe you make space along that edge. And we've talked about the Kīlauea fault zone over here and a connection to the East Rift Connector and Southwest Rift Connector and all of that. And so that might be something that's going on here right now. You can see a little bit of that pattern right through there. All right, if we scroll down a little bit more, we don't normally focus as much on these, but we have to mention that this week there's a big blue earthquake over here. It was a 4.1 down in Pahala within the last couple of days here. It prompted a USGS information statement, 4.1 on August 18th. That was yesterday, 2:02 a.m. local time. Depth of 20 miles. So it falls in that same pattern. No changes to the volcano. It's just not something we're going to dwell on anymore today. But to put things in context over the past year here's the earthquake rates of the past year. So you can see that the last earthquakes per week value up here came above 600 as we expected. So that is higher than we've seen in a little bit, right? It's close to the highest we've seen post-eruption, but not quite. It does make part of this elevated background level that we're seeing, comparable to what we saw prior to the eruption still. So we're still at elevated background with these smaller variations week to week to week, and sometimes this half a week and that half a week being different as well. Even though those earthquakes might have seemed alarming, they didn't last long enough, didn't go on long enough to reach us to this level of spike up here. So that's the level that we would like to see to be more convincing that that's going to actually move to eruption. So it was working its way there. It didn't last long. It wasn't persistent enough and wasn't intense enough in the end. So but that gives us practice what to look for. We'll wait what happens with that. And that on the map looks like this for the past month. So you can see if I just showed you this map first and foremost, you might be a lot more concerned. But at this point in time, there's so much nuance week to week that this is not really getting that resolution we want in time. It's kind of just smushing it all together. But you can see the interesting regional patterns that we described before, right? That seismic southwest rift and that upper southeast rift and south flank and all those patterns that we've described before. So move on from there and show you guys it this way, right? So this is automatic generated animation from the Iris earthquake browser here, and this is a similar histogram plot here showing earthquakes per day. And I've set it to the whole last month here, and I'll just animate it for you guys so you can see the earthquakes coming in first up here on the summit, and East Rift coming in bursts, quieter times, and then here come a couple flurries. Here comes one around the beginning of the month. Here's the 5th, and then really the 8th through the 10th is when we had that larger flare off, and then quieter, and then back up since then. So that's the pattern we're seeing here. Nothing really that unusual. We can come into the most recent earthquakes map here and see if there's anything unusual or alarming. Let's see, 2.0, 2.4. There's really nothing that unusual going on a recent earthquakes map here. So let me move on, and we'll look at the tremor a little bit here. And the tremor is something we've been looking at from time to time, and it's not the easiest thing to read, but we'll talk through what's going on here. This is a collection of seismographs around Kilauea. These are at the summit. And today has been a pretty windy day up here at the top of Kilauea, so I imagine that most of what you see here is daytime wind coming in at the bottom, most of the signal you see on most of these stations. You do see quite a few other earthquakes, some bigger ones, quite a few smaller ones out through there. You know, maybe you see some other tremor, but it's hard to tell that this isn't also wind in the middle of the day yesterday, for example. So if we scroll down, we can see that a lot of the stations have these similar patterns and similar signals. I kind of like this one, the outlet that's showing not a whole lot of wind signal, but it does show one band of tremor right through here. So we might be having some tremor embedded, something like that, where it's happening from time to time, but it's not persistent, it's not super pervasive. If we look for that particular band across some of our other seismographs, here we do see it picking up a little bit in the East Rift area, right, and all around, kind of, you might pick up that band all around, vibrating the whole East Rift and South Flank and kind of everything around there by the looks of it. So that one might be real, and it's not something you see. The wind isn't as pervasive everywhere, so there might be a little bit, but it's not a whole lot, right? So we'll leave it at that for now. But we will now switch to the tilt, and this is a tilt across several summit stations. Here's Uwikahuna on the top left. You can see that there was a little bit of variation up and down, but the overall trend of rising is still ongoing. At Sand Hill, it's a little bit easier to see, a little bit more evident. Rising, not super fast, but steadily. Right? At Kīlauea is interesting. It has just recently come back online. And it's showing, let's look at the scale here, microradians. So we have 2 hash marks as 1 microradian. So only 3.5 top to bottom, so not a huge scale. And I'm not sure what this little spike is right here, if it's something to do with some local effector calibration, but it's interesting to see it actually does appear to be rising at a fairly steep rate, although not a huge amount yet. We'll just see if that means anything, or if it's some kind of relic. I only look at it a little bit more suspiciously because we've seen that earthquake flurry there in the last week or so, and so it may be that the magma is filling that whole Caldera area as well as that southern, southeast, southwest part of it as well. So it could be something like that happening as well. Summer camp's not showing a whole lot. We don't really see anything that exciting anywhere else. Scale being very small over at Pool, and not much signal anywhere else there. All right, so a couple more things here, since that's the plots pulling off of the map here. Here's the official information page of the USGS. Here's the tilt in the last 2 days, in the last week, and the last month is what I showed you guys right there. And so moving to GPS. GPS is not showing us anything as we suspected last week. We have a data gap. So the data is not coming into the automatic plot anyways. I'm sure it is coming into the observatory. It's just a matter of probably changing some processing, some of the software or something like that, and it's not updating all the way. And it is not just this one, it's every single GPS plot on the USGS webpage is doing that. So that's why we suspect it's something systematic and nothing localized, and something to do with the software issue there. And since we will talk about the USGS GPS campaign and GPS fieldwork, maybe there's some associated upgrade of that monitoring equipment as well that we're going to hear about. So, but to wrap it up, before we take a pause and discuss some of our viewer questions and say our thank yous, here is the USGS source of this update, the weekly update from this past Tuesday. The volcano is not erupting. There's no real new information in here. It's fairly similar to what we've seen before. The new sentences here refers to that increase in seismicity that they say, the slight increase in the rates of seismicity along the summit. Let's try that again here. The slight increase in the rates of seismicity around a summit upper east rift zone early last week has not persisted and has since decreased. So that's really the important thing. That's what we've really shared with you guys here. And they're still saying upper east rift zone replenished with magma. By contrast, the lower east rift zone was mostly quiet. All right, Dane. Let's say some thank yous and
get into some questions as well.
Yeah.
We do want to throw out some thank yous to begin with. We have some people that help make this stream possible, and we want to acknowledge them. First, we have some donations on hawaiitracker.com/support. We appreciate all those, but if you want to help support this stream, best thing you can do right now is like, subscribe, and consider sharing this on other social media platforms. It really does help. With that, I do want to acknowledge the people that did make monetary donations, John S. and Michelle B. We also have 2 sponsors that we like to thank, and they really do help put this, keep this going. First one is Kaleo's Bar and Grill in the heart of Pahoa, and it's really a nice little restaurant with unique twists on some traditional dishes and a little bit of local flair to it as well. Great for anybody visiting or locals as well. Indoor, outdoor dining. I know a lot of people are thinking more about that outdoor dining with the COVID numbers. So they do takeout as well. So definitely consider Kaleo's if you're coming into Pahoa for dinner next time you're about or around this way visiting. Second sponsor that we want to thank is Kalani Tours out of Kona. And they have a few different tours they offer, but they're all smaller scale tours. It's not the big tour buses running around and just shuffling people about. This is more about really getting that intimate knowledge of the local area, as well as a little bit of contextual understanding of what you're looking at. They also make sure nobody does anything crazy that is going to get them in trouble, like taking a trail in a rainstorm that's eventually going to force people to get rescued. There's going to be none of that. But yeah, definitely we appreciate all of our sponsors for helping this go forward. We also are brought to you by a grant from the Hawaii Community Foundation, Puna Strong Grant, and the County of Hawaii. So we appreciate all of them.
Mahalo, right, everybody.
How about some questions, huh?
Yeah, let's see what we got.
All right. Stefan asks, how does magma stay hot? It sounds to me it can remain viscous for so far from the origin heat source, at least how I see it. So like the lava flows over land and just how long they take to cool.
Yeah, I mean, it really is kind of amazing, and that's really why I like to say that when a magma's at the surface, it's really all trying to freeze as quick as possible wherever it possibly can, right? It really comes down to the fact that to the thermal properties of the rock, right? That rocks don't transmit the heat very quickly, right? They'll stay, if they're hot, they'll stay hot, and if they're cool, they'll stay cool for a while, right? That's kind of it, right? So that's basically it. They are essentially freezing nonstop as they're traveling through, and that's part of why a lava flow that's trying to go some distance across some flat land will eventually choke itself off and branch out because they're essentially freezing all the time. Yeah, absolutely. Even small pahoehoe flows, I just see them spread out across the surface. You see that crust form immediately within seconds, and then the inside's going to swell up, and it's insulating itself to be able to essentially flow on that small scale. And then, of course, that leads to lava tubes, and lava tubes allow you to transport lava flows much greater distances without a whole lot of temperature loss, right? I want to say that they measured lava coming out of the ocean entry through a lava tube after coming out of Pu'o, and it was something like only 5 or 15 degrees difference in temperature out of a couple thousand, right? So it really is not losing a whole lot of heat when it's insulating, and I think essentially comes down to that, the insulating property, and in the way in which it flows as well. Yeah, but good question.
It's a great insulator, and the more insulation you add, the better it insulates. So the thicker the lava flow is, the better it does at keeping itself hot.
Yeah.
So yeah, good question. Appreciate it. Next one, I found a little something. I put it in the link in the text for you, but I was hoping you might have something. Nicholas asks, are there any records of Kilauea levels prior to 1924?
Yeah, there are.
Yeah.
There's all kinds of stuff. Yeah. I can show what you threw up here. What's this view of 1923 landing field in Kilauea? There's all kinds of photographs, and we've done histories of the Caldera before. Maybe I can throw this up here. Let me find. This is a plot that Thomas Jagger drew here. This is showing 1909 at one side over here, and 1935 at the other side here, and this is elevation, so 3,700 feet, 36, 35, 34. So there is lava lake levels varying up and down, and then it explodes and it drops way down, and here's the refilling. So I started off our examination here, and we just look at this side of it right here. But there is record going back, right, of course, from further back. This goes back to 1909. 1909 was the first records. Frank Perret coming before Thomas Jagger, but before the founding of the Hawaiian Volcano Observatory. So this is the most detailed record keeping we have. There are snapshots of Caldera before that, and there were occasional visits by surveyors who'd come and survey once every few years, kind of thing, and get the shape of it in that sense. So we have that as well, but continuous. This is what you're looking at right here.
Right.
Yeah, mahalo,
Appreciate
Nicholas.
We have a $19.99 super chat from L. Lauer. Pronounced that wrong, probably. Appreciate the super chat.
Mahalo. Mahalo.
Let's see here. Next question. Also from Nicholas, and I saw this one a few other places, so I figured I'd let you address it. Are there any kind of tremors taking place on Kilauea currently? Any spasmodic tremors or just harmonic tremors going on?
So I mean, I showed you guys the seismograph there. That's all that we have to look at. There's nothing official coming out of the USGS to say anything about that, and I haven't noticed anything myself either. So I will say that I am separating Kilauea from that whole Pahala zone, right, which is kind of its own beast, and there might be something happening down there that's, if we were to dig deeper in there, but that's separate from Kilauea, right, and treat it that way here today.
Right. All right, I think we have one last question here for this segment. Talking about, Heidi asked about the earthquake in Mountain View the other day. Was assuming that it was Mauna Loa settling and depressing the seafloor. Is that correct?
Earthquake in Mountain View.
Yeah.
All right, let's see here. This one, perhaps? 2.4, that was north of Mountain View. That one was 4 kilometers down, not super deep. Yeah, I mean, I would probably call it a settling earthquake as well. Yes, Mauna Loa settling, but also Kilauea to the side moving around next to it. The combination of both, I would say, right? Maybe not only Mauna Loa, but Kilauea in addition to Mauna Loa as well, and not only that, but even Mauna Kea away from that does its own settling and its own ride of sinking as it moves away from the hotspot as well. So there's all kinds of adjustment happening all around that area of Mountain View is kind of buttressed, right? Kilauea, Mauna Loa, Mauna Kea, all could be candidates for what's going on there. Yeah, but yeah, good first instinct for sure. That is that northeast flank of Mauna Loa area. That's the closest place for sure.
Yep, good instinct. That will do it for this series of questions. We will collect some more and do one more Q&A at the end. So we'll pass it back to you, Phil.
All right, sounds good. We're going to switch to a little bit of show and tell now on the most recent fieldwork photographs USGS has shared. So we'll start over here. This is going back to August 3rd, their gas mapping. So there's a few more different views just to see here as well. And so I'll make sure we go through the captions to see what we can learn as well. So they are sharing some little nuggets of information here and there in various places, right? So they do say that they continue their survey of the Caldera floor, including a down-drop block. They're looking at a large crack that's emitting gas and steam, and they're going to compare this to what was happening before 2018 as well. So there's that little bit of gas you can see. Let me zoom into it here. A little bit of gas coming out there. You see a little bit of deposits on the walls of that crack right through there. That's what they're looking at in that first photograph. And here's that south sulfur bank on that south side of the caldera. So when you go to Kīlauea, you're a little bit over that way from here. But this is one reference point that we can use across all of our photographs here, with the pit being further over to the right over there and the lava lake visible. You can see the edge of it right over here, right through there. Maybe I can zoom in and see it a little bit better right there. Yeah, that's what it looks like. Hard to tell exactly, but maybe you can see it in there. Okay. There is that edge of the south sulfur bank. You can see how it's actually yellower in this one area. And see, this suggests active sulfur degassing coming out through the cracks here, much more so than other areas to the side, which are also parts of the old sulfur bank. And you can see the discoloration and mineral deposits as well, but it doesn't look nearly as fresh as what you see over here. All right, and all the way down, and in fact, all the way to the bottom, there's a little, we have to zoom out to find it. There's a little, there it is. Another little spot here that's discoloring the rocks and depositing that characteristic yellow hue on those rocks there from sulfur. And so here, their caption. They talk about the north margin of the south sulfur bank. Light colored deposits are evidence of ongoing alteration from volcanic gas emissions. Here at the bottom, bright yellow sulfur deposits are a stark contrast to the darker gray basalt rocks, evidence of ongoing gas emissions in the area. So yeah, I think I hopefully said that. Here they're taking this, what they do is they take the syringe and they put this hose down in the crack and they can suck in some gas. And then they're pushing it out of the syringe into the sample bag, it appears. And this is a bag that they can take back to the lab to analyze. Yeah. Check it out here. They say that they were measuring carbon dioxide in particular. So that's what the caption is telling us in addition here as well. So this area of that south Caldera wall, you don't see as much sulfur, but what is interesting is this little patch of different rock right through there. That's a patch of that ash, of that explosive ash. It's called the Ue Kahuna ash that you see as evidence of all those explosions that Don Swanson has followed has studied to great extent. And mostly it's up on a rim, but clearly some pieces of it have fallen in as well, along with everything else. And here's one piece sticking out through the rubble right there. Interesting to note. And I believe that is what the caption describes as well. The lighter colored volcanic ash, likely the Kīlauea tephra deposits from the last explosive phase several hundred years ago. And a note that there are tens of yards or meters of lava flows above it here. So it's quite a lot of lava covering it up. And so that's the stratigraphy of this part of the caldera here. The ash came out first and laid blanket across everything, and then lava's come and covered it over and over and over and over and over again. So it got that thick before it all cracked and got exposed so we could look at it here. All right, continuing our photo tour here. Here's a view of a gas geochemist, USGS, carrying that multi-gas tool on their back, right, hiking across in transects across the floor here. We've seen a little bit of that before. It's just a slightly different view of it. They are measuring CO2, SO2, and water vapor, as well as H2S, and they're going to make a map out of all of this, which we hope to see someday. And here's that view of the 1982 fissures from a down-drop block to the south of that inner pit of Halemaumau that I showed you guys at the start of our broadcast today. They say that eruption lasted approximately 19 hours, April 30th, 1982. 0.6 mile fissure, 1 kilometer long, that came northeast of Halemaumau, and part of it collapsing in, but much of it remaining intact. That's the wider view, but if you can actually get in pretty close and see some of the detail of the topography down there still as well. This is an area that the old Halemaumau trail used to go along this backside of this. And I'm sure there's pieces of the trail still there, but of course you can't get there anymore. The area is being closed, and not only that, there being a cliff in the middle of the trail now. So that's the 82. This is the last ones of Kilauea. So there is that down drop block. You see a bunch of rubble here. Here's that edge northeast of the pit of the lava lake, and it looks like right in there you can see some gas coming up. You can see the edge of that lava lake right there, as well as some more sulfur coming out, and all the rock slides you can see adorning the walls here. Interesting there. And I believe that is noted from the northwest corner of the largest downdrop block within Kilauea Caldera. HVO scientists were able to spot the southern edge of the lava lake that was recently active. And this is part of their gas survey that they were doing. This is a view of Pele's hairs. So these golden strands here are very thin strands of volcanic glass. It's almost like a natural volcanic fiberglass. It's like a spun glass. It's not unlike a cotton candy kind of thing where you have something molten that's being pulled apart and then it freezes in long strands. And it's collecting downwind of the caldera here. And a lot of this likely from the lava lake era from 2008 to 2018, where quite a lot of gas bubbles were bursting and lots of strands of lava were getting billowed out in that plume and blowing downwind. So it collects in the cracks and still visible extensively across the landscape here. And that's the view of the gas survey going around all the sides of the caldera here, and that's what that is interesting to note here. Actually, this notes this on the eastern part of the caldera in an area that did not collapse in 2018. That's what our caption is telling us here. All right, so that was the gas survey, and there's also a GPS survey ongoing. And there's one photograph of that here. You can see they're having air support. This is over in the East Rift Zone. Let me come in closer here so you can see how this actually works. All right, there's a permanent benchmark set in the ground, and they'll come and bring the tripod with the GPS on it. Right, they can come and they can center this tripod directly above it. It's got levels and sights and things. You can look through the hole and align it right to that little X right on that benchmark and get it exactly in the same place every year. And you leave it there for a while. You might leave it there for 24 hours. Sometimes you might leave it for less time if it's harder to get to come back to it, or you might leave it for longer, depending. So in this case, you see they're flying out and setting it up and probably leaving it for a while before they come back to collect it and collect the data. And this allows them to collect GPS signals from more places than you can have these live monitoring signals. We show you guys the live monitoring all the time. But those are only a handful of places that have the radial transmitters to bounce it back so it can get onto the internet. And they do broader, more comprehensive surveys all around, ideally every year if you can, if there's not some giant eruption happening that summer, for example. So that's something that's happening now, and it's reflecting that all the activity on the volcanoes is happening underground, and so we really need to make sure we're collecting as much data on the surface to try to interpret what's happening underground. So we'll await those results and interpretations from the USGS as they come in too. So that's the USGS on Kilauea, but there's also Mauna Loa, and so Mauna Loa is also in part of this yearly survey here, and this is on Mauna Loa on that southwest rift with a nice clear view of Hualai volcano over here. And they note, west flank of Mauna Loa, and the annual survey supplements the continuous GPS stations and provides information on vertical and horizontal deformation of the ground surface. So it says that it's been completed recently, this survey. So that's a southwest rift view. Here's a view looking with Mauna Kea, so looking more to the north. Mauna Kea is visible over there. This looks like Hualai over here. GPS station right there. They note 33 campaign stations are occupied during an annual Maunaloa GPS campaign. And the stations are spread across the flanks and give a synoptic picture of the information over the past year. So this one is something I can zoom into you guys a little more so you can get a little bit better view here of that station. On the flanks of Mauna Loa, Mauna Kea behind it there. Bring it across over here to the Kona side. You can see there's a little bit of kohala under the clouds right back here. You can see the trade winds blowing the clouds, and there's that wet and dry line across the island right there. A nice view from this site. Oh, that's actually Maui back over here. This is Haleakala and Maui. And back over here, Waialae. Nice panorama there. Let's see if that's all. Not all of that is noted in this photograph, but it is all in the photograph here. Another view here, this one on Mauna Loa on the north flank. Clear views of Mauna Kea. The metal disc in the ground beneath the tripod is a benchmark, which is cemented to the lava flow surface. Each year, the unit is centered on a benchmark, and the height of the GPS unit on the tripod is accounted for when calculating how much the spot has moved vertically and horizontally over the past year. And so there's another view of that. Maybe there's a better view of the benchmark, and in this one there, you can maybe see it. A little bit blurry there, cemented in the ground. You probably maybe come across these if you're hiking around, and that's one of the purposes for them. Is for these yearly campaigns, especially on these active volcanoes. All right, and then here is I believe the last one. Waialae visible. They do note that Mauna Loa GPS campaign service sites mostly been occupied every year since 1996, whereas the less active volcanoes of Waialae and Haleakala are surveyed every 3 to 5 years. So if anyone was wondering about Waialae and Haleakala every 3 to 5 years, depending on what else is happening there. And there's that view of that GPS station. Yeah, that's GPS stations at different spots in Hawaii. You know, people have their little plush toys and take them all over the world. And here's a picture of the plush toy and next to the Coliseum and next to the Eiffel Tower or what have you. And here's our USGS version of it, GPS stations. Different places, different backgrounds here. So we'll finish up Mauna Loa here and wrap it up. Here's the Mauna Loa GPS. Hasn't shown anything different in a while, although we're also missing data for the last week here. But this is just the one station that's cemented in the ground. Right? If we scroll up here to this upper map, this shows where the stations are in Mauna Loa. These are the ones that are able to radio back all the time, and they have more stations all over the place that they're augmenting as well. So this is one of the rare times we have to wait both for the live data and for that additional network data, just because of this, whatever is happening with this GPS maintenance of the website here. So, but we do have the Mauna Loa update to go on here. They do note ground information measured using GPS measurements confirmed the volcano is not moved appreciably over the past week. And likewise, that's what told us on Kilauea that GPS was still inflating, was the USGS update there. So 58 small magnitude earthquakes, slightly up, still on a low end of things here in that same region beneath the summit upper flanks. So not a lot of change there. We can look at the past week map as usual. Still that little cluster northwest, not super active, but it is showing a little bit, and same to the southeast, upper southeast flank, and a little bit still in that uppermost southwest rift too. So it's a little bit more active than it was in previous weeks. We can look at the past month view here, both in map view, similar patterns, and we can look at the earthquake rates and depths here. So you can see it's really been a variable in Mauna Loa as well. There were some days with 0 earthquakes, which is really unusual. And then we're really up to maybe 16, 18 here at the top, and then back down here at the bottom.
Yeah, I'm still wondering exactly what is green conditions for Mauna Loa if it's not this. The USGS update says there's no change in ground deformation. The earthquakes, there's days where we have 0 earthquakes. It's like, what more do we need for that volcano to be declared not really doing anything? right? We can always bring it back up to yellow, like if need be. But as of right now, what is it doing, right? Because it was yellow 6 months ago or 8 months ago when we actually had a signal, right? It's not the same right now as then.
Right. Absolutely. Yeah, for sure. We're still expecting it that a downgrade is justified at any point in time. It has been for a while already. So if it comes, we will not be surprised. We're only surprised by the fact that it has not come yet, seeing as it's been, if we look at this graph here, the GPS we just had up, it's been since April, right? Since that change happened. So, and yeah, here looking at the earthquakes rates for the past year, you can really see that it's really been back then too. So here you can see April was that last peak. And since May, really, it's been fairly low earthquake rates here. Earthquakes per week is what we're looking at now over the last year. And in a range of 50, less than 100 per week, really since May consistently, which is a lot different for any other time during the past year. You can tell by this graph right here. So that wraps up Mauna Loa. Yeah, we won't be surprised to see it downgraded at some point. And if we have any Mauna Loa questions, we can talk about them, or other Kilauea ones.
Oh, yeah, we're back on Kilauea, I think. So we have 2 questions here. I'm going to rephrase both of them because they weren't phrased as questions. Matt Hackor says, talking about Kilauea Iki and the depth in which the lava was erupted from, thinking that there's a deeper supply for the Kilauea Iki region, and the reason why he brings that up was related to on August 11th and 12th, there was looked like a flurry of earthquakes over Kilauea Iki, right? So he's wondering just kind of what your thoughts on the dynamics of that plumbing system might be.
Yeah, for sure. I mean, it's all published. Yeah, I mean, there definitely was a deeper source, but it definitely displaced shallow magma as well. So I think the thing that I would just, I suppose, what I would suggest to consider is that there's very easily multiple pathways that can exist into the thing. It's not a simple path, one way in, one way out that we might like it to be. But I imagine that there is a deeper source, and there's likely a shallow connection as well, right? Because we do know that the whole Isla lava shield that fed that long-lasting eruption was all coming out of that side of the Caldera, right? Because all the flows spill to the east, and none of the flows spill to the west, right? So that's the side it was coming out of, and so there must be some long-term connection to that long-term supply as well, right? And that long-term supply is something we've mentioned, I think last week, the week before, how there could be, maybe it's been 3 weeks now, we saw the deep earthquakes, how there could be up to 3 deep pathways into the volcano. And that's not even getting into the shallower pathways as well. So yeah, absolutely. Yeah. So I imagine that what we're seeing now is probably the shallow system getting activated by just spreading of that caldera inflation area, right? That's what's interesting, is you don't always see that happen at Kilauea Iki. And we're not seeing the deep signals there exactly. There are deep signals around the area, but they're not in a pattern that suggests magma is coming from that area exclusively, let's say, or primarily or abnormally or anything like that.
All right. Next question comes from Nicholas. I'll rephrase this one a little bit as well. Was asking about the gas measurements and different ways in which they might be taken. Focusing on gas being preserved in either rock or Pele's hair, and that being able to be sampled later and do like a geochemical analysis on that. Have you can you speak on that a little bit, maybe?
Yeah, absolutely. I'm very, very, very far from being an expert in this, but I can tell you a little bit about it. Yeah, certainly the gas is trapped in everything, right? So if it's trapped in the volcanic glass, which is essentially what Pele's hair is for the most part, you maybe can get it out of there, but you have to worry about how gas can diffuse through the glass as well. There may be some limit of how long you can use that technique for, right? Because at some point it all diffuses out of there if you just have some amorphous glass. So a lot of times what is done is you look for crystals that grow around these bubbles of gas, and you have gas trapped inside of some kind of crystal. And not only can it be, I mean, the crystals can also be eroded by being remelted and that kind of chemical process as well. So there are ways you have, variations. And so if you can find something like that, you obviously need to know when that gas got trapped, but you can actually start extracting different age gases from your magma as well. And I would imagine that's, like I said, I'm not caught up to the research by any means. I've just, exposed to it a little bit when we talk about all the different Kilauea processes at the yearly meetings and all that, right? But yeah, certainly there is gas everywhere. It can be tested, and it's got all kinds of things you can learn. And not only that, but there are people way smarter than me who know the diffusion rates and which minerals to target and which phases of the magma cooling process that they're actually targeting with that, et cetera, et cetera, et cetera, et cetera. All kinds of details involved there.
All right. Well, that does it for questions today. We will be premiering another episode of Drones On immediately following this live stream. Not a long one. It's on June 8th and 9th of the 2018 Kilauea eruption. So I hope to see you guys there. And pass it back to you, Phil. Aloha, everyone.
Yeah, mahalo, Dan. We'll look forward to that. Yeah, everyone check out the Drones On, and we will be with you guys in another week unless something changes, right? And at this point, really expect the eruption to be declared officially over, being in the news next week, and we can maybe reflect a little more, although we've done quite a lot of that. It's been a while since eruption has been practically over, even if it's not officially been over till next week. Yeah, so we'll look at that a little bit and see what else is going on and what the patterns are and go from there. So mahalo, everybody. Mahalo for your questions, for your interaction. Mahalo for your contributions. Not just your thoughts, but those of you guys who donated. Mahalo. We really appreciate that. It really keeps us going. Mahalo to all of our sponsors and grantors as well.
We do have a $35 super chat that just came through from our friend Gary Bryan. We appreciate it, Gary, as always. Good to see you.
Mahalo, Gary. All right, you guys. Until next week, ahui ho, until we meet again. So from HawaiiTracker.com, he is Dane DuPont. I am Philip Ong.